Hi, everyone. I'm going to lead you through some exponent properties or exponent rules. From here on out, we're actually going to be doing most of our notes in a notebook. So while I have this on a sheet, you should actually be jotting these down on a sheet of paper, preferably in like an actual notebook. And we'll talk more about that in class. So let's just go through these, the properties. I'm going to do a couple examples for you. And then, yeah, that's basically, that should be a short video. So we really have 1, 2, 3, 4, 5, and then one on the back, 6 properties that we want to talk about. A lot of these we already know. So I'm going to start off with an example. I'll kind of explain what that example is in general terms. And I'm going to also over here talk more about what can you do if you forget? Because I can write in words what we're doing, but I think it's more powerful that if we forget, if we have a skill of how we can actually remember and come up with these properties on our own, that's way more powerful. So that's what's going to be in that last column there. So I would jot this whole table down. If you need to hit pause to do so real quick, then do that. So first example, if I have x cubed times x squared, that is x to the 5th. And the reason how I got that is I took that same base and added the exponents. So x to the a plus b. That is the general rule for when we're multiplying same base exponents, we're going to add those exponents. So if I forget, how can I figure it out? This always comes down to what do exponents really mean. If I've got x cubed, that really means x times x times x, right? X times itself 3 times. And if I'm multiplying that by x squared, well, I'm just going to extend this and do x times x. So how many x's do we see? 1, 2, 3, 4, 5. And there's x to the 5th. So then in my head, I can be like, oh, yeah, to get to 5 with 3 and 2, I have to add those, right? So that's a way to help me figure out what operation do I do with the exponents. All right, well, if multiplying means we add the exponents, dividing means we're going to subtract our exponents. So this is x to the power of 1 or just x. So x to the power of a divided by x to the power of b is x to the power of a minus b. And a way that I could help with this one is, again, kind of the same idea as write out what x cubed means, x times x times x, and x squared, x times x. And because this whole term here is multiplication division, anything divided by itself is just 1. So let's cancel out, leaving us with just 1x left over. So basically this right column always just ends up being what exponents really mean. Okay, moving along. 2x cubed. One thing that is confusing a lot of people is that 2 stuck to the x? Is that 1 term, 2 terms? Well, it's actually 1 term, but the 2 and the x are being multiplied. So I like to think about this as 2 times x. And for some of us, it might help to always write it like that. So this property here is telling us that both terms are in here are getting cubed. So this is 2 cubed times x cubed, where 2 cubed is 8. So this is 8x cubed. So our property here is if we have multiple bases that are multiplied, raised to an exponent, they both get that exponent. So x to the a and y to the a. Now again, if we write out what this means, 2x cubed, that means 2x times 2x times 2x. And we just talked about that 2x means 2 times x. This is 2 times x. Again, and one more time. And I can be like, okay, I've got 2 times 2 times 2, or 2 cubed. Then x times x, which is x cubed. All right, this one actually kind of combines with the one that we just did, in that if I have an exponent raised to another exponent, we actually need to multiply those. This is x to the 6th. So I can figure that out. Or in general terms, that's x to the power of a to the power of b is equal to x to the power of a times b. And same idea, if I have x cubed squared, remember what it means to square something, multiply by itself. So it's really x cubed times x cubed. We know x cubed is x times x times x. So I'm like, how many x's do I see? 1, 2, 3, 4, 5, 6. So x to the 6th. And I'm like, how do I get from 3 and 3 to 6? Or excuse me, 3 times 2, we multiply those, right? 3 times 2 is 6. I was looking at the wrong numbers there. Okay, we would add those in that case to get to that same 6. All right, and the last one, negative exponents. The way I describe this one is we always have a location, and by location, I mean either the top of a rational expression or a fraction, or the bottom. So if I have a negative exponent, we need to first change its position. So we either take it from the top to the bottom or bottom to the top. So this is 1 over x. Let's take it to the bottom and make the exponent positive. So in general terms, x to the power of negative a is 1 over x to the power of a. I'm gonna save this explanation. This one takes a little bit more time. So yeah, that's all we're gonna have for that property there. All right, so what you're gonna work on are a bunch of different exponents. And one thing that we wanna know is, how do we know if something's completely simplified? Two things have to happen. You need to have no negative exponents. And no repeated bases. What I mean by repeated bases is you shouldn't write X more than once. See how over here I've got an X there and another X there and a Y and a Y. We shouldn't write those more than once. We need to find a way to combine those. Okay, so no negative exponents, no repeated bases. All right, well, let's do just a couple examples. I don't think I need to do all of these. Yeah, we'll do 3 of these, and I'll keep it pretty quick. So first off, when I see all these things, I don't see any operations here, which implies that everything is being multiplied. So the use of parentheses here actually don't matter either. So one way we can view this is x squared times y times x cubed times y to the 4th. It can be really helpful to write it out like that, especially for those that struggle with this. So I'm going to work on my same basis. So x squared times x cubed, that's x to the 5th. And then y times y to the 4th is y to the 5th. Pretty straightforward there. Okay, over here, again, it might help for me to write x squared times y to the 5th, and x times y cubed. Well, we're going to worry about just the same basis. So x squared divided by x, I subtract those exponents, and I just get 1x. Y to the 5th divided by y cubed is y squared. Not too much. All right, 2 more. Number 3, anything to the power of 0 is 1. Now, I can just assume that. I can also use the property, what we saw up top here. So an exponent raised to another exponent, where I have to multiply the exponents. So this would be 1 times 0 or 0, 3 times 0 or 0. B, negative 1 times 0 is b to the power of 0. All these things to the power of 0 is just 1. So that was just a long way of me saying it's just 1. Okay, last one is this 3 here. And this is a really good example as to why I think it's beneficial to write out these multiplication signs. Because what a lot of students do is they know this 3 needs to get distributed, and they usually call this x cubed and call this y to the negative 3. But what a lot of students fail to do is they fail to take this exponent and put it on the number. Okay, that exponent applies to every single base. And if we break this down and write out what it means to cube it, we'd have to write all these things at least 3 times. So this is really 2 cubed times x cubed times 3 cubed times y to the negative 3. So we have some things that we need to do first. We need to do 2 cubed, which is 8. X cubed, there's nothing I can do with that. So we're going to leave the x cubed. Y to the power of negative 3, well, we can't have negative exponents. So if I've got this y to the negative 3 in my denominator, I need to change its position and bring it up to the numerator and make the exponent positive. So the only thing left in our denominator is 3 cubed, which is 27. Now, one thing that we need to do, and this is more from Math Excel, is reduce down any numbers. So does 8 divided by 27 have any common divisors? They do not. So 8 27ths is as reduced down as that number can get. So this would be our full simplified expression. 8 times x cubed times y cubed divided by 27. Right. I'm going to skip the other 2 on here, and I'm going to go ahead and talk about one more property, and then we'll end this video. So x to the power of 1/2 and x to the 1/3, this is actually another way for us to take square roots or represent square roots. So anything to the power of 1/2 is the same thing as the square root of that base. So square root of x. X to the power of 1/3, that'd be the same thing as cube root of x. So in general, x to the power of 1 over a is equal to the 8th root of x. So what we wrote down is that anytime we have a denominator, and when this is an exponent, it becomes that same numbered root. The denominator becomes the root. So just a quick example of this, let's say we have a fractional root where the numerator is not 1, rather 3 or 5. Okay, how can we rewrite this as a radical or with a square root expression? Well, that denominator becomes the root. So this is the square root. The numerator stays on that x. So this is really the square root of x cubed. And that's it. Okay, that is as simplified as we can make that. Okay, same thing over here. Since my denominator is 3, this is the cube root. The 5 stays with the x, so it's x to the 5th. And that's basically it. The rest of this, I'm going to just leave as is. You now have a Math Excel assignment with more practice. Thanks for watching and have a great rest of your day.